And I started recording already so that there's no doubt that this will be recorded. Always feels like a telemarketer, right, with these things. What can we do? Hey, Tony.
Olá.
Olá. Como você está? Como está você?
Bonjour.
Bonjour.
Bon
Ça va
après-midi.
bien? Comment vas-tu?
Good to see you all.
Yeah.
Hey, Phil. Nice photo.
Yeah, I'm here. I got a noisy background though, so I'm going to be.
Okay.
Always great to see you guys and learn from you as well.
Fantastic.
Yeah, I also have a bit of a noisy background. I'm hoping that this will help today, but you know, we try. That's all we can do. There's so many issues. I mean, the students have so many connectivity issues, and they are in places where, like, there's a student who's taking my classes in a closet. And
I got a student with the closet too, yeah.
Yes.
Closet.
Yeah, and because you see all the clothes hanging, and because it's the only quiet place they have, they can concentrate.
Do you require them to have
The camera
cameras
on? No, only for the test. So, but they voluntarily, you know, from the beginning of the semester say you will need a camera for the test. And I guess to show that, yeah, we do have breakout sessions, and microphone is certainly essential.
Yeah, I've had some students in breakout sessions that really haven't had the microphone.
Yeah.
They send their stuff on the chat, which is kind of interesting.
And mics are really cheap. I mean, microphone, come on.
I have some students who don't even talk. They just work on their own in the breakout room sessions. And it's a hill I haven't been able to climb yet with them.
Yeah.
So if they're using the chat, there's a step up.
Tony, I am recording already.
Oh, are you?
Oh, I am already.
I think I've already said a couple of outrageous things. I don't know what I'm gonna do.
I already put them on YouTube, Tony. Don't worry.
Yes.
Evidence.
I have a colleague of mine. Yes.
Do you want me to take notes?
Okay, we can, but also I'm recording, and I have the recording set up in my Zoom so that the chat gets all recorded as well. I get the recording and the chat's all saved in the directory. So that's for sure. Sure, you can take notes, and then sure, we can do everything.
And send it to the listserv.
Oh, that would be great. Then, if I don't have to, you know, re-edit anything, go ahead, please. Yeah, we like that.
Sounds good.
Have you received, Chris, any email from APT asking you to submit the you and Dean the description for your section?
No.
Not yet.
No.
Oh, shoot. Let's see what's going on. It's maybe it will take a while, but it should be coming soon.
Okay.
I was so happy that we don't need to do that for you, that they would ask you directly.
Yeah.
So that I hope that I am recording the chat using Star Trek software. What?
Star Trek software.
There is such a thing?
Yeah, what's going on?
Live long and prosper, I guess. I don't know.
It's a bad joke. It's a bad joke.
Oh, I see. Okay.
Dean, I apologize. I realize that since I don't have a schedule or a routine, I apparently just can't keep track of anything. So
it's okay. I'm busy enough doing everything else. I probably wouldn't have looked at anything you would have sent yet anyway.
I got emails that are a couple weeks old. I haven't gotten to those yet.
It's really bizarre since I don't have any routines right now. You know, it's like, oh, what day is it? Is it Friday? Is it Friday yet? Like, it doesn't matter if it's Friday. Every day's the same.
I still have that problem. I'm just happy if I have the right notes for the right class.
Yes, exactly. It's day by day. I'm moving one step at a time, honestly, these days, and it's getting busier.
I had a lab group that asked me, when's the next lab due? Like the lab after the lab we're doing. I'm like, I don't know.
Yeah, exactly.
Really? You want to work that far ahead? Great.
That's why I write it down and I post it, because I can't remember.
Yeah.
That's what I tell the students. You have to go look, because I can't remember.
You tell them it was due yesterday.
Oh yeah. They'll freak out. They'll freak out.
Oh,
Hey,
man,
Dwayne, nice to see you here.
Hi, Dwayne.
Hey.
I got some students that are so on edge, I'd be afraid to do that to them.
That makes it more fun.
People are still trickling in, so let's give it one more minute or so. Emily, I like to see you here. Hi, Emily. Now I connected the face and the name. So we have at least 2 speakers already lined up. 2 people would like to hear something about is Emily on her book on analyzing physical phenomena, and it's from Oregon State. Emily and Elizabeth wrote this book. It's an open source book. And then after Emily, in principle, I also heard that Dean Stocker can say something to us about spiral physics and parallel pedagogy. And then the forum is welcome to anyone who would like to point out things, any open resource material or things that they would like to share with the group. New things or things that are already being shared in our website or somewhere else. And this is your chance to showcase. And then we can just chat. Well, let's see where the wind takes us. So this is being recorded, and we'll post all of these I'll post on the website again of the ABT website, and I'll send you an email with the highlights. Emily, would you like to tell us about this new book? We need the sound.
There we go. Okay, my name is Emily Van Zee, and last spring I was teaching a lab-based course for physics course for future elementary, middle school, and teachers. And I was challenged to do it by Zoom. So that inspired me to provide a poster at the summer meeting, which I'm going to share with you. Maybe, hopefully, there we go. And I chose to use the 4th unit of the course for the examples. And so the poster is called Engaging Prospective Teachers and Learning About Climate Change via Zoom. But what it really was intended to be was an advertisement of the open source textbook that Liz Jury and I have been developing, which finally got published this summer officially. So if you're interested in it, you can access it through open.oregonstate.education at Physics for Teachers. And what I'm going to do is share a different, oh, that's interesting. Can I share a screen?
Yes, you were sharing the screen before and it worked very well, and you were allowed to share. Yeah.
There we go. Okay, then I want to go back and share it in a slightly different way.
The link to the book, Emily, I posted also on the TYC website. Yes. I can show that later, but it's there.
This is not what I wanted to share. This will take me a minute. There we go. This is what I'm trying to share. Come up. Okay, so this comes in the way of it. All right, so the title of the book is Exploring Physical Phenomena, What Happens When Light from the Sun Shines on the Earth. And we have 5 units. 1 is exploring the nature of light phenomena. Unit 2, exploring the nature of thermal phenomena. 3 is considering the influence of light and thermal phenomena on local weather. And the unit that I chose to take examples from is Unit 4, considering the influence of light and thermal phenomena on global climate. And we do have a Unit 5, which actually extends throughout the entire course, exploring the nature of astronomical phenomena in the context of the sun, earth, and moon system. They watch the sun and the moon, and towards the end of the course, they use their observations to develop explanations of day and night, the phases of the moon, and the reasons for seasons. We also have handouts for each of the units that you can access. We have a 10-week example schedule, an example equipment for remote learning, because I had to turn it all into what they could do at home, and so forth. Each unit has the same structure. We start by identifying resources, what the students already know about the topic, and then we develop some central ideas based on their explorations in class using everyday equipment and materials. They develop central ideas to explain some kind of intriguing physical phenomena. Then they develop mathematical representations of that phenomena and use the mathematics to estimate a quantity of interest. And because these are future teachers, we make connections to educational policy and the next generation science standards. And then I'm going to show you some examples from Unit 4, maybe. Everything goes well here. No, didn't go well. Try that again. No, I don't want to close the current tab. There we go. Okay, so let me move this over. You can see it, maybe. All right, so we were fortunate in moving to Zoom in that we were already, for most of our explorations, using everyday materials, such as, for example, here, we're modeling the difference between ice melting on land and ice melting in the ocean.
Emily, I think we can only see like a screen of your, like the application, the file manager. Okay, try that again, and maybe we'll see you were referring to a PDF file. Maybe you wanted to open the PDF file, and we were seeing just the file manager. Oh, yes. Oh, yes.
Yes?
Yes.
You're seeing what attempted with homemade materials?
Yes, we are.
Yes.
Yeah.
Good. Okay. All right. Well, then we're together. So these are 2 frozen dinner trays with 3 ice cubes and a rock that's flat and water filled to the brim. And after a while, everything melts. And you see that if the ice is on land, it's going to flow into the ocean and rise the sea levels. So that's an example of using everyday materials. We also focus on line graphs, and this is a graph of many different glaciers all over the world that are melting at an increasing rapid rate. And so we can use those excerpts from the text, but I abandoned making the analogy between the graphs of falling balls and melting glaciers. If you look at the position versus time graph for a ball that's falling, it looks somewhat similar to the graph for the melting glacier. And we had the students playing with motion detectors on campus, and I just said, well, that's not really going to work for me versus Zoom. So I abandoned that, but some things did work well. One was documenting students' initial ideas through ungraded surveys, and that's through Canvas. So that worked well. And I was leery about using the breakout rooms. Initially, I started by just talking at people, but eventually I moved to risking that, and I used the ungraded surveys to guide those explorations. And here's an example. And then also, here. What also worked well was continuing our friends and family experience assignments. Every other week or so, we asked them to teach a friend or family member what they learned in class themselves. And although you're not teaching future teachers, your students are teachers if they attempt to teach somebody else. And so I would recommend this if you are interested in doing this. You can see examples of our assignments for engaging students and talking with others about what they're learning. And what worked really well for me was I continued the custom of exit tickets through the ungraded surveys, and every student after every class answered what was most interesting about what you learned today and what are you still wondering. And this was a wonderful way for me to have a direct connection to what the students were thinking. And so I actually thought that this was going really horribly, to be honest, compared to what happens in class. But I did do a end of course survey, which made me happy because the students, although I thought it was a disaster, seemed to have learned what I wanted them to learn, which that science can be fun and interesting, and there's lots to learn there. There we go. Thank you very much.
Awesome. We open questions from the forum. Anybody would like to ask a question to Emily about this work and the textbook that is freely available? It is in our website. When you go to resources, you see there are books. There's an item called books, and then you see there. Emily, are there mathematical steps also in the book? Every chapter, do you offer like end of the chapter problems? Like what is the mathematical, do you have some mathematics used there?
Yes, these are our students are going to be teaching K through 8.
Yeah.
So I keep the mathematics at that level.
Sure.
They do need to be able to use a linear equation to solve for A over B equals C over D to solve for D.
Yeah.
In the pinhole phenomena and in the conservation of energy for the thermal, the change in temperatures given different masses of the hot and cold water that they're mixing in. And then we insist on they learn about line graphs, simply because I think understanding a visual display of changing phenomena is important for them to do. So,
for everything, elections, politics, the economy, anything.
Whatever.
Yeah.
So we push on that pretty hard. And they do range. They have had an elementary, a course for elementary, a course in mathematics for future elementary teachers before they come into this class.
What I have to say from my point of view is we have a physics for health careers, more technical course in our institution, and we use the Physics of Everyday Phenomena by Griffiths, the book. It's so expensive, and they only need it for a semester. So we are always trying to find something, and the level of math, I mean, the college physics by OpenStax is too high of a level for them. So we wanted something low, but also not zero. So it's been hard to find something in between. So
well,
that's,
you might be able to adapt something from this. I have to say that I had the privilege of working with the Physics for Teachers programs at the University of Washington for a decade. And then I went to the University of Maryland, where the Powerful Ideas in Physical Science was largely developed or partly developed with their Physics 115. I was teaching the Elementary Science Methods course, and I saw the advantage of the students who had that physics course when they came into my methods course, and understanding what it means to teach through inquiry. And then Fred Goldberg had been a sabbatical visitor at Maryland, at Washington, so I knew about the everyday physics, and I tried to teach with that initially in this course. And I adopted their idea that in developing a physics problem, you need to think about what is the situation and what are the relevant physics ideas that are important here before you get down to the details of what's told and what you're supposed to do. So those were all three of those different Physics for Teachers programs have been very influential in my background and motivated a lot of what I do and what Liz and I do in the course.
I'm glad you sent an email to the whole list, and those who are interested in getting in contact with you, you have Emily's email, right? Because she addressed all of us. Yes. And you can also get in touch with me, and we posted the link to the book.
I need to say that I have in fact retired, and so my email for this list is vanzemily@gmail.com, and I watch that every day. And also I'm still a courtesy professor at the University And that's the Van Zee with 3 E's at oregonstate.edu. Also, in preparing today, I changed the poster a little bit, and I'm going to send Glenda a revision of it if you can post the revised.
Okay.
There were some typos I was shocked to see. I have made a new one. If you can substitute, it'd be great. Thank you.
Okay. We are also getting some comments on the chat, and yeah. All right. So anybody would like to speak up, or otherwise we will pass the word to Dean. Maybe, Dean, if you would like to say something about Jean and Chris, I think you're both working on something together related. You're organizing a session for the summer APT meeting. It's the summer, right? I think it is next summer, on parallel pedagogy and spiral physics, version 2.0. Okay, Jean already posted. And would you like to say something?
Sure. Yeah, I'm probably the least experienced teacher on this call, so I feel a little weird presenting things. These are basically a lot of ideas that I stole from everyone else, and I'm trying to put it all together. So what I just shared is a document. I'll share on my screen as well. So screen 1, there it is. Okay, so I was introduced first to parallel pedagogy, so that's how I think of it. But if anyone doesn't know what spiral and parallel are all about, it's basically changing the order of how you teach physics. So with spiral, with spiral, he goes through all of the ideas, force and motion and momentum, energy in one dimension. Once you cycle through that, then you cycle through it all again in 2 dimensions. And then you cycle through it all again with rotation. And parallel pedagogy is very similar, but more extreme, I guess. Within the first week, you've actually touched all of those concepts of momentum, energy, force, and motion, and on a very surface level. And then with every iteration, you just add more and more and more to it. So the hardest thing to me, I love doing it, basically because in the general physics class that I teach, not using this, I hate that when we get to chapter 7, the correct answer to all of the questions is momentum. You get chapter 8, and the correct approach to everything is I hate that.
Okay.
This way, I can present something to the students and say, okay, you know about all of these ideas. What concepts are most important? And I think, Emily, that's exactly what you were just getting at. It's a very similar idea that, here's a situation. What do you use to go at it? So that's the motivation for doing this. So spiral physics, that's been around for a long time. And this link, so it's on Compadre, if you want the information there. He has textbooks for algebra-based and calculus-based and labs all developed there. So all of that information is there. The parallel pedagogy, that was put together by Pete Schwartz, and it was published about, I think for the first time about 5 years ago. He collects all his information here on his website. He's got some videos. So I've got a link to his YouTube channel, and he also has a lot of them on PlayPosit with built-in test question or quiz questions into it. So if you would like to get those, you can contact Pete. Got his email on here. Myself, I've got a few video demonstrations that I put together just because I like video demonstrations, especially when we're not in class, but it's hard to find video demonstrations where they don't explain exactly what's going on. And what I want to do is show my students a video and have them tell me what's going on. So just for example, here's one, dropping 2 balls at different times. You ask them what's going to happen, and then they watch it and find out, oh, that's what happened. Or if you drop them from 2 different heights, this is now a different video, you can see the distance stays the same between them. But that's all it is. It's really, really short videos, most of them, no explanation of physics. So if you need something like that, those are there.
Mhm.
Then Pete Schwartz has his calculus-based textbook, and it's sort of like a workbook almost. He also has an algebra-based one. Then we work together to make a conceptual one. So that's what this one is. And then next page. This is actually the book that I'm using in my conceptual physics class for this year. And I've got, not here. Well, there it is. It's available on Lulu for $11. And it's available for free, the digital version. So this is it. To give a basic idea of what it's about, we're starting 2 objects right now. So this chapter is what happens when 2 objects interact. So there's a page where it just talks briefly about what we're going to do in this chapter. Then when you flip the page, it's oriented sideways. So these 2 pages open up reference frames. So you see this for reference frames. Then when you flip the page, it's something different. Reference frames, we're talking about how 2 objects move relative to each other. Then arm wrestling is the next example. So what happens when you're arm wrestling? So this is now really like Newton's laws of 2 things against each other. And everything is split words, graphics, and numbers. For my conceptual class, we don't use the numbers column. I wrote this with the thought that hopefully they'll let me start using it for the algebra-based class later. So this is here. If my conceptual people like it, if they don't, it's fine. Ignore that column. There's color coding. The blue stuff is about forces. There's gray. It's hard on this screen to see the difference between gray and black, but gray is related to motion. Turn the page. Now we're kicking horizontally. Green is momentum. Red is energy. So you can see forces, energy, momentum. So that's the way it's all set up. So that's the way the book is set. And yeah, so every time you flip, 2 pages is about something different. Summary at the end of each section. Mathematical models are then laid out for the section. And I put restrictions on the validity of them here because I hate when students use them when they're not useful. And so hopefully that will help.
Ah.
And then there are questions that I order in order of like difficulty in terms of how well did you understand the material. So that's the book. And I put all of these questions into my Open Math. So they are available and self-grading online through my Open Math, and I can't click on it because that thing keeps popping down about screen sharing. But anyway, I could show you that, and I think that's it. In a nutshell, that's all of the resources that I know of that are available for this online.
You know how you play when you play cards and you play, well, there are other games. I like canastra. We call canastra in Brazil. My family's all Italian and all. And you know how you hold your cards and you have this amazing game and nobody sees. And then all of a sudden you drop everything. It's an amazing game and you win the game. That's what you just done. How come we don't have all these links on the website yet? I mean, you've been holding all this. I should have squeezed you more. Like, give me the information. I don't know. Wow, we're gonna post all this.
To put her part in.
And boy, you and Emily now we just want to hear about people who are writing books. Oh my God, all these books, fantastic.
Well, I feel this book really just started existing in this form very, very recently. We started kind of working on it a couple of years ago, and this one I like better than the previous version. So it's the first one that isn't so embarrassing that I can't show anyone. But
I finally moved towards being willing to let other people see what we were doing. I had the privilege of working with some of the main people in the field, Lillian McDermott and Fred Goldberg and John layman. So I was embarrassed to show anything that I was developing, but I got to the point where, well, it was so much work, and I'm now admiring so much any book of any kind that anybody has written. It's a huge amount of work, and so I admire what you're doing. That's wonderful. The multicolors will help people like my daughter who asked her geometry teacher what color an angle was because she apparently sees colors, and was just not encouraged at all to study mathematics after that. So I think it's wonderful, and separating those different ways of thinking of the words and the math language being separate from the visual, I think is really important. Awesome.
Joe, you have some nice comment here. If you want to turn on your microphone and say it out loud for them to hear. I don't know if you are.
Well, I will if you think it's worth it. I'm just, the computers have changed everything, and I realize that's a cliche, but it's also a true cliche, if you will. And I think we're finally beginning to see authors like Emily and Dean and many others begin to change the very meaning of the word textbook. And I think this has publishers shaking in their proverbial boots, because we now can control this narrative thanks to all this embarrassment of technology that we have in front of us now. That, my God, 35 years ago, this was witchcraft. I mean, we had Halliday and Resnick, and we had a brick and mortar library. There were no computers. You had to be a grad student to have access to a computer. And I had a Commodore 64 in my dorm room. That was huge in 1985. And I see lots of people nodding out there, so you know exactly what I'm talking about. So I think this is great. And having produced 4 books myself, I understand the embarrassment with, nobody wants to see this. This is terrible. But you'd be surprised, because there are other people out there doing similar things, and we want to compare what we're doing with these other sources of innovation. So I think this is a good thing.
One thing that's different in our book is that the physics for teachers at the University of Washington, when I was part of the staff there, was totally hands-on, without any pieces of paper whatsoever. At most a handout. There was a question and some equipment was provided. And that was the way that I learned to teach, other than talking at people, going from group to group and asking a question or making a comment as needed. And so when I was asked to design this course at the OSU, that's how I started, with just doing things in class. And I accessed the internet as resources for people to look at that were relevant to what we did in class after they had done it in class. And so our open source textbook is unusual in that there's URL after URL after URL for people to enjoy applications of what they just learned about, as distinct from the discussion of what the ideas were that you learned in class. But that has problems in that URLs change. And so this open source textbook is current as of July 2020. And who knows what will happen afterwards.
Well, thank you for your participation. And I would like to hear a bit, because I know Faruzan, are you here? Faruzan?
Yes, I'm here.
Yes.
Hi, Glenda. How are you?
I'm good. Because I know, Faruzan, you have some great laboratory materials too, and we haven't had the opportunity to share that. I don't know if you're ready or if you would like to say something about it now.
I was just listening to everyone. It's the same feeling. I feel they are terrible. And so basically what I did, I went to our classroom, to the lab room during over 2 days in the spring, and I videotaped 20 labs. So I basically was the student performing the labs. And so now that I look at it, so each of those turned into a 15-minute lab, which it was the labs that we do at Santa Monica College. So I just basically took the data, just did the experiments. And these were for the calculus-based physics class and for the third semester of physics, which is waves and sound and optics and all that. So I have those, I can share them, but honestly, they are terrible. But they're a good resource to go to just in case, you're really in a bind. So yes, I can share those.
You shared the link right at the beginning of this talk. You shared this, right? You shared the link.
No, that's a different link. So a couple of weeks ago in Southern California, we had a new teachers workshop, put by someone from SCAAPT. And I went there, and the high school teachers have a lot of resources. There are all these. So the link that I shared is a list of a bunch of different simulations. It's not just a PhET. There's a whole bunch of different things, all organized by topic. And it's a great source. I put them in my pages of Canvas, for my students to go and, explore.
Okay.
So that's what I shared. But the labs, yes, they will be coming. I'll
okay.
send them to you, but they are, yeah. Take it with a grain of salt.
I think there's a perfectionist behind it. Got it. And Tony Musumba, recently on our app, on Slack, you shared a good link for all of us too. Do you want to say something? Tony, are you here?
Oh, okay. Always happy to say something outrageous. Well, I was sharing some stuff from Next Gen PET, Next Generation Physics for Everyday Thinking, which is physics for elementary school teachers. So a couple of us in the 2-year college community have been teaching the pre-service teachers using these materials. It started off as PET, Physics for Everyday Thinking, but it's evolved into something else. And so there's a community of people from 4 years, 2 years that do that. And they came out with a link that I posted on Slack. I can look for it. Or Glenda, you can.
Yeah,
for me,
I think I'll be slow if I do that. Yeah. And
so it was something that the community talked about what they did during the transition to online teaching. And so there's some helpful tips there that could be of help to us, even though we're teaching calc-based physics, college physics. I think you can get some help out of that. Yeah, good to see you all. I'm supposed to be teaching in California, but I'm in Bismarck, North Dakota still. So it's a fun semester. But I made the transition to California, and I'm regretting it already, David. That's about all.
Thank you, Tony. Anyone who would like to chip in, go ahead. Any collaboration? Yes, go ahead.
Share a lab if you like.
Oh, yes. Anyone can share the screen anytime you want. It's all available.
So we're doing all our labs online. It's really hard with circuits. And so this is sort of my Band-Aid for this semester. So I can send this to anybody. I'm not sure how you want to share it, but I basically took a series and parallel lab and I made it into something you could do with that PhET from Colorado. So I have students that kind of have to work through this on their own using the PhET. And the idea is they figure out the rules involving series and parallel circuits on their own without me just telling it to them.
Yeah.
So you've probably all seen this PhET before. Let me see if I can share that real quick. And I've lost, there we go. I think I would have gotten the hang of this by now, but basically they use this PhET. It's the link inside the lab, and they build their series and parallel circuits using all this materials. They can put in a battery, they can put in resistors, they can determine what resistance value they have, and they can connect them up with wires. And there's a couple nice features where they can see the direction of the current, can show the direction of the current in here. I also made one for a Kirchhoff type of lab. And what it showed me is that I don't know how accurate the algorithm is in here, because I've done this Kirchhoff activity in class before with real resistors and so on, light bulbs and stuff. And it told me there was no current. So I'm not sure how good the algorithm is, but it's good enough to get through this semester, hopefully. And then there's also meters in here, so they can go in and they can measure, what the voltage is on each of these different resistors and so on, that kind of thing. So I can share that with you if you like. How would I get that to you, Glenn? I just email that to you?
Or post it right now, and yep, or email me. Yeah.
How do I post it? I have it's a Word file?
Then wait.
Okay.
We'll figure it out.
Okay. I'm not that tech savvy yet, I guess. I'm working on it.
You can share files in the chat area, definitely. Yeah.
Can you show what happens when you've got too much current?
Does it burn anything? Does it melt anything? Does it?
It's beautiful. Yes, it catches on fire.
Ah. Oh, cool. I do like that one. Yeah. That's less of a cookie cutter. They really have to build the circuit and play with it.
I wish there were an option to show the drift velocity in real time. That would be kind of cool.
There might be something that FET does that might simulate something like a drift velocity when they do their resistor stuff. But I don't know. I think there's something like that.
Okay, so this is a recurrent question while giving some time for some of you to think if you are wondering what you could share or if you want to share something. But how many of us here are teaching some labs or something face-to-face? Yes, David Everett is. Dwayne is teaching some components face-to-face. David, you, and I think Eric was also teaching some face-to-face. Yes, and our last 2 weeks ago, our last meeting, we had Eric and David sharing their experience and how actually what the outcome for me was that it was quite positive, that the students were thankful and appreciative that this was being offered under the circumstances. And we would like to hear the F2F people speak face to face. Do you have any new updates, more things you'd like to say? Well, yes, David.
So I'm just doing the second semester of calculus-based physics lab. So circuits, basically we're doing circuit experiments face-to-face. That's the only part I'm doing face-to-face. And the more I think about it, it's working great. But the more I think about it, that's partly because these are students who are second year of calculus-based physics. So they are really serious students. They're in calculus 3 at least, and they're really motivated to learn the topic. So it works great. They're very compliant with all the rules, and there's some students who have to work from home because of health issues, and then we'll connect them to somebody by Zoom. And so they're like a Zoom partner, and that works well with these students. But I can imagine it not all sort of falling apart with some other groups of students. But for this, it's working great.
Eric, would you like to add anything? Because I know you have experience with this, Eric Jensen.
We're all online at Chemeketa.
Oh, okay. I don't know why I had the impression that you were also because you shared a lot of materials last
Wayne
time.
is the one who's face to face too. I want to hear from MCU.
And if you don't know what MCU is, that's Mean, Cruel, and Unusual. It's a nickname my students came up for me about 15 years ago. We're like David, our primarily any of our calculus-based sequence has at least some face-to-face component. What we were actually able to do is we got our administration for the classes that are going to be face-to-face is cut our cap down a little bit. So we actually have lower enrollment in the classes. And what we're actually doing is we split. So if we have 24 in the class, we actually have 12 in one classroom and 12 in another classroom simultaneously. So we actually have everybody there, but only 12 students in a classroom, instructors going back and forth between the two. Okay. And so we had the luxury, because so many other areas decided not to do anything in face-to-face, we've been able to do that. So it's actually worked really well. And I would agree with David, because this is the calculus-based sequence, we also did it with the first semester. And we also do an integrated learning community. So in most of our calculus-based classes, it's integrated calculus physics and a calculus class. So I say the instructors are going back and forth. What that means is the calculus instructors in one, physics instructors one, and then we flip-flop depending on what we're doing. Okay, so there's always an instructor in the room. Don't go away saying, you know, EMCC lets our classrooms not have faculty in it. But we found it's actually worked really well, and the faculty have been very receptive to it. The one thing that we did do, and we made it as a cognizant decision in our entire physical science division, is if you have to do only online because of medical issues, we're a part of a 10 college district. All other 9 colleges offer courses you can take that way. So we encourage you to take it at a different college so that we don't actually end up with the situation David described. Now, of course, somebody gets it in the middle, you know, and has something come up, that's a different issue. But at least at the beginning, that was the deal when they signed up. They had to understand that they had to come. And it's actually worked really well. We haven't had any issues. As David said, the students have been very compliant and very willing to follow the rules. And we actually, you know, 2 people per table, we actually have plexiglass shields between the students. So that all kinds of different things. Our college invested heavily in to get us to be able to do some face-to-face.
And okay, so but do you have the lower level, the algebra based or even more technical courses also being taught face-to-face over there in physics?
We do not. The algebra trig based, which for us is primarily for the pre-professional, the pre-meds, pre-pharm, is all online. We actually have about a third of our conceptual physics classes face-to-face.
A third, got it. So I was reading the other day that the enrollment in the whole community college in all of California, and California being the largest ensemble of community college in the country, is the enrollment is down a lot. And maybe that, of course, there are some exceptions, but the average is down. And that may be a reflection all over the country with some pockets of exceptions here and there. And they were trying to explain that as being the case that, well, it's exactly the students that don't have internet access, don't have access to all the technology, that have less means of monetary, financial means, etc. Those are the ones that are being more affected. And those are the ones that come to community college a lot. So that's why we are seeing our population seeing that a lot. I don't know if you guys have any comments on this at this point.
Our college was down. But our physics was up. Well, our calc-based physics is down a little bit, but our algebra-based physics was way up. Can't explain it. And we have some students who come to our school as opposed to other community colleges because our labs are fully online. So,
David.
Oh, I was just typing it into the chat. Somebody asked about distancing, and I thought I'd say we're splitting into 2 cohorts of 12 to come in to do the same experiment on alternating weeks. And so there's plenty of room in the lab for them to have their own lab bench and be distanced properly, and their own set of lab equipment to work with. And then the folks who didn't come in that week are doing an online different lab, maybe something with PhET simulation, like was just shared. And then we flip positions on the next week. Mike, I have a colleague who's teaching the pre-med physics, and he's also doing an in-person lab, and it's actually going pretty well too. And he's doing it completely by, well, half the class will be a Zoom partner with the other half who's in person. to do one experiment. And then the following week, they do a completely new experiment. So you only got one experience of it. Either you got the Zoom experience of it or you got the in-person experience of it. And then the next week, they flip roles. And it's going reasonably well too. So I shouldn't say it's only that you can get the calculus-based students to comply with things, but I think it's harder.
Thank you, David. The other thing I would like to add is while we wait for anybody else would like to chip in, go ahead, or I don't want to monopolize, but for instance, changing the subject to tests. I have a colleague in my college, and I know she doesn't mind that I mentioned that she's at her wit's end. She's this close to quitting, she says. And now we're like, oh my God, don't do that because we'll have to take over everything. But she is really, this past week were a lot of tests, they were online tests, and she's having to do a lot of makeups because of internet connection issues that the students had. And it's like dozens of makeups, and she's trying to do all the different versions and all. So this has been a nightmare for her, and this is my week coming now. My week of tests is approaching. I'm also so for those of us who try to do the test during, the class time and give a few minutes, 10 minutes, 20 minutes before and after, but we can't extend. And I mean, and we don't want to do a take-home exam. I guess a take-home exam wouldn't incur into those issues, but. Yeah, so internet connection is going to play a huge role for us. Have you guys had stories to tell so far about issues with tests, or good things to say about good alternatives, good way out, solutions you're finding for applying tests?
Let me inject something in here that we've experienced at Austin Community College in Austin, Texas, and that is that the students will have a second device and they'll be on Chegg, posting the question to the Chegg and getting an answer back on the second device and then doing their exam. So we've had to have the students actually have two devices on, and the second device is on themselves. So the scholastic dishonesty is rampant during the COVID. I can just tell you, it's worse than anything I've ever seen. And I've dealt with some pretty bizarre stuff over the years.
At the last AAPT coffee talk, break, whatever, that happened on Tuesday, somebody shared something they do on their exams that I'm going to try. The professor from Cal State Chico said, instead of just solving the problem, which you can get on Chegg, she has them almost write an essay of why the formula is used, why this step was used. So all of her questions are essay questions with physics and math embedded in it. She obviously says you can't do timed exams that way because it's going to take a lot longer. But all of the questions, the students have to give as much written detail of why they used something, what the strategy was. So almost like all of our publisher textbooks where they have the 4 steps, the strategy, the math, the solving, and then they have to explain whether their answer makes sense or not, which a lot of times we don't follow to them too much. I know I'm guilty of that. But yeah, that's something that I'm going to try on my first test coming up October 6th. So I hope I'll tell you how many complaints I get from the dean after that.
Yeah, here was another solution that we jumped into with, and that was much like yours. We informed the students that there would be an optional one of the problems for which they would be given an oral questioning, and that pretty much scares the heck out of them. It's like grad school all over.
So I'd like to talk about how I dealt with cheating. So I did have 2 students during a 50-minute exam where everyone was on Zoom upload their exam to Chegg, get solutions posted on Chegg in time for them to copy the solutions while taking the 50-minute exam, which I was just really surprised and shocked at how quickly that happened. but I was able to pretty quickly and easily identify the student on the first exam and the student on the third exam who did that. And in both cases, as one might expect, the students were working 40 hours a week. Their roommate or their significant other had lost their job, so they were having a hard time meeting bills, and there were other extenuating circumstances in their life. And the conversations I had with both of those students in order where we worked on restructuring their academic plan, I think was very useful for both of them. So I think the thing I'd like to sell is when you do find a student who's cheating, there's probably a good reason they are in their life issues. And I found working with those students was productive for both those students. And I would like to ask you, Trap, how did the camera from the second camera work from the student's point of view?
The voice.
And
yeah, I was muting there. I didn't do it, so I can't really tell you how they physically connected it. So I can certainly get back with the gang, but it's a pretty doable sort of thing. And it has to do with your choice of how you're conducting your online test, whether you're using, we use Blackboard Collaborate. It's a little bit more capable of doing multiple things than Zoom is. So that may have been the issue.
For me, I used Zoom. Students took pictures or scanned in their exams and uploaded them to Gradescope. If you haven't used Gradescope, I found Gradescope a great way to grade homeworks, exams, and anything that was handwritten and to be scanned in. It really saved a lot of time.
I've been using Blackboard to grade, and now they improved. I don't know, my college at least is paying for an improved capability, or I can write with my pad, and I can really go say choose a question, because I'm doing them to solve a question in one page, each question a page. So at least that makes it easy for me to figure things out and grade page by question, file by file. So far, I'm finding that unless I haven't explored Gradescope, I've entered and I looked at it, but I'm finding that the first things I saw about Gradescope looks like Blackboard is achieving it. So so far I'm okay.
Does anyone use D2 Desire to Learn? I'm trying to find a way where I wish I could just have that PDF and I could write on my iPad and grade it without having to type all that stuff. I don't know if anyone has a solution to that.
That's what I do in Blackboard. I can do that in Blackboard.
Really? Okay.
I think Theo is asking about Desire to Learn. Is that your LMS that you use?
Yes. He's asking if there is a way in D2L to do that. What I see in Blackboard is the students submit a file, right? Well, I don't know if I need to show this, but I don't know if that is something that is interesting. Let's see. Well, anyway, I'm gonna, just for the sake of it, anybody who wants to speak up, please speak up. I don't think I'm gonna show anything too revealing here, so I'm just gonna go and keep showing. I'm thinking at the same time I'm doing this, I'm like, am I going to show anything that's too revealing? I hope not.
So Glenda, as you're showing that, I mean,
yeah.
D2L would be a little different from Blackboard, right?
Oh, yes, but they should all provide the same kind of capabilities. So let's see, I agree. Let's see, let me go to this one.
I think Canvas also has a capability of writing stuff on it.
Yeah, I do that in Canvas regularly. That's how I've been grading tests since last spring.
This is notebooks. I've graded all the things. Oh, let me see. I have one that I haven't graded yet. Yeah, I think I shouldn't show student names, right? So that's a problem here. Let me see what I can do. I can just get out of this. Let me not share the screen right now, and then go to, but I need here, I go to the needs grading and I see what they submitted. So let me say, let me do stop sharing. And so for instance, I get here, I see what they are sharing, the files, and then I just scroll, oops. And here you go, this was Oh boy, you cannot see the name of the student. Okay, so now I'm ready to say those things. You gotta be thoughtful. Oh boy, where am I now? I have lost touch here. Let me see. Now I'm gonna share the screen. Let's share. Okay, now hopefully you're seeing. And yes, so yeah, so the student is here and I do this, I annotate and I choose the color. Yes, I'm doing red. There's a lot of people who say don't use the red, but anyway, I go here and and yeah, I go with my board and I can write whatever I want here, right? And
So
I
are
can
you
also.
using an iPad?
I'm using a pad
Okay.
and a pencil. Yes, but I also have a notebook where you can write. All right. So yeah, so this was from the experiment on tossing the ball up, right? The gravity. Yeah, and so on. But hopefully you got an idea. So I was happy. I'm happy with so far with and I have a chance to type, so I can also type. I don't think there's anything secret here yet. I can give a comment, leave a comment, and do the grading, and that goes straight to my grade book. So I think it works. So so far I'm okay with it.
So I have a question. Wondering something. Before, when we were face-to-face completely, a lot of the percentage of the grade of the class was test-based, right? Like 75% was basically based on the final and exams and quizzes. I am wondering if everybody's still following something like that, or your percentages have changed. So I just wanted to put that out there.
Things definitely changed for me. Definitely. Ours changed. Okay. Would you like to speak up instead of me doing a poll?
I was changing things anyway before the pandemic struck. I have continued to change. I've gone to just a straight up accumulate points sort of a scheme where students who claim things like, oh, I'm no good at tests. And I say, well, do more homework then, because get points somehow. That said, there's still a preference for tests. Tests are worth more points. Tests weigh a lot heavier, but there are alternative routes to a good grade for students. So far, they've responded. They like the idea. It has not made any statistical difference in what grades they managed to achieve. I had one group that I had started with. I had a group of students last fall who continued with me last spring when I changed the scheme, and comparing their grades in the fall class to the spring class, they weren't different. People that got A's still got A's. People that got D's still got D's. Didn't make any difference.
Chris has a question. Is anyone using standards-based grading? Joe? I think
I'm sorry.
I think Gloria is proposing she will have a workshop this winter meeting on mastery-based grading. Gloria Ramos, she's not here with us today, but what's that?
I tried to register for that workshop and it's not listed in the registration for some reason.
It has been confirmed, so I guess it's coming. There are some things that were like late additions that weren't updated, and now it's been confirmed. So I guess this information is slowly being updated.
I think it's only for masters, that one.
Huh?
I'm joking, but
okay. Boy, this meeting went by fast, and now it's already 4:58. What I would like to say on the, Farouz and I would like to say I also have been trying to change the approach on the percentage of how I grade the students every semester and try different things, because I still haven't got to a point where I can say what is perfect and what is the best. And I find if there's one inspiration I have from all that I've learned, like even with Tom Okuma and all, and it was amazing when Tom would come or Dwayne or all, but Tom, I remember clearly, he said, yeah, this semester I'm trying spiral physics. Next semester I'm going to do whatever. They changed they changed the method of teaching and try different things like from a semester to another. That is was amazing because we know the amount of work there is when you change the methodology. But this is it. You are really experimenting, and that's the only way you're gonna know what works best. And so I changed now because it is online class, but also I've been changing anyway, so I don't see it as necessarily a bad thing now. Yeah. Well, unless we have any other comments, any other input from any one of you, we are going to wrap it up now, 5 o'clock, it's been 1 hour, and we shall meet again October 9, that is 2 weeks from now, and that is going to be for a discussion, an open discussion, and we start on the topic of, well, what are the long-lasting changes we think are going to come out from this COVID-19 impact, right? And then the conversation takes us wherever we want. Okay, so that's October 9, 4 p.m. again. We're going to have a host for this conversation. I'm not going to be the host. I'll leave Dwayne to do it all, to host us. We miss you, Dwayne.
I'm excited. I
have a
move my
comment.
schedule around to be here for these from now on. So being 3-hour time difference makes it harder.
Is it possible for us to be slacking a little bit more?
Of course it is. This Zoom meeting is at least on until 5:30. So
The pun is intended.
okay. So
Slacking.
yes. So thank you all for coming. Those of you who cannot make any further, we are wrapping up. But those of you who would like to stay longer, you're welcome to stay. I'll be here too until the end. And Zoom lacking. Zoom lacking. Dean, thank you. Thank you, Dean. And I'll get all these links online.
Thank you all.
Bye-bye.
Good to see you all, man.
Yeah, I was a bit late. I had a super exciting meeting with the campus, well, the networking people from the university in Reno who are now taking over management of the computer network at my college. And they were shocked to find that my observatory was on its own network, which I had to almost literally punch people to get a year ago. So it was a fun meeting. It went well, but yeah, I would rather have spent more time with all of you.
Or do you want to stop the recording?
Did they let you keep your network?
Okay.
Oh,